Hello! In this video I will give a brief introduction of UIElements, a new retain mode UI framework for Unity. UIElements borrows concepts from the web's CSS, jQuery, the HTML DOM, and the event system, and makes it easier to create and optimize UI in Unity. In my demo here, I have an object, a tank, and it has a script attached. The script has two variables, tank name, tank size, and in the update loop, just for fun, I update the game object name from the tank name and the scale from the tank size. So if I change this to a 2, the tank gets bigger. Now I'm going to briefly start by talking about IMGUI because I want to give UIElements a little bit more context. So here's my IMGUI editor window, and it has the same UI as the inspector. It is also linked to the same object. So let's look at that code. Here's my IMGUI editor window. In the onEnable call, which is called when the window loads, I get a reference to my tank in the scene. And then because IMGUI is immediate mode, I need to rebuild my UI every frame. This happens in the onGUI call. I've just moved everything to a separate function because I'm going to actually use it elsewhere later in the video. So this function is not the ideal IMGUI code. It's just to illustrate some concepts in immediate mode so we can compare them with retain mode and UIElements. So first off, I save a copy of my background color, the global background color, because I want to change it and then I want to restore it later. To do this gray background on the row, I need to create a texture, set it to gray, and I use the texture to create a style, and then I use the style to create this horizontal scope, which is my row. For the label, I create another style to set its font size and font style, and then I draw the label right away with the text IMGUI, which you see here. Then I create another style for my text fields. I make sure to inherit from the global text field skin because I want them to look like fields. And then I again change the font size and font style. Now I could draw the text field right away, but I want to just get the rectangle of where the text field would be because I want to use this rectangle to check if the mouse is over this field. If the mouse is over the field, or the would-be field, then I change the global background color to yellow. Now since I already have the rectangle, I can draw my field on top of this rectangle. So I draw my text field, and this illustrates a common pattern in immediate mode, which is the field takes the initial value and then immediately returns the same value back or the changed value if the user changed it. And because this all runs every frame, I always have my tank in sync with the field and vice versa. Same with integer field. I use the same style that I use for the text field, but I set the background color, the global background color, to blue before I draw the integer field. And then finally, I restore my global background color from the one I saved above. So that's immediate mode. Let's see UIElements and retain mode. If we look at the UIElements editor window, we see the same UI again. It's also linked to the same object. But I implement each row slightly differently, all in UIElements, to show different features of UIElements. So let's look at that code. Here's my UIElements editor window. In the onEnable call, I again get a reference to my tank. Now because UIElements is retain mode, it means I can build my UI once using objects and then have the system render it for me on demand or when it thinks it needs to be redrawn. The core component of UIElements is the visual element class object, and every editor window has a root visual element. So you get this root using getRootVisualContainer. And once you have the root, you can start adding your own child visual elements to it to form your hierarchy. So the first thing we add is our inline C# row. So I create a new visual element object. I set its styling. To set the gray background color again, all we do is set the background color to gray. And because this is my row visual element, I want the children to be laid out in a row in a horizontal way. So I set the flex direction to row. I then create my label object. I set its text in inline C#, which you can see here. And again, I set the font style and the font size. I also immediately add it as a child to the inline visual element. Then for the text field, again, I create it, I add it as a child, I set the initial value, so this is just the initial value that the field will get from the object. And for the integer field, I also set the background color to blue. And then I add the entire row as a child to the root. So this is the first thing we add to the root, and it's the first thing that we see in the editor window. Okay, I briefly want to take a look at the debugger. We have a debugger. We see here the root visual element, and it has several children. The first one is actually this background image. Because I wanted it to be behind the fields, I have to add it first. I just do this separately just to make the demo a little prettier. But then the very next thing is the visual element that we just created for this inline C# row. And if we expand it, we can see it has the three children: label, text field, and integer field. We can also turn on overlay to actually see what we're highlighting. Okay, now I mentioned CSS, and that's because UIElements has its own brand of CSS called USS. It follows the same spec for the most part, but there also are some minor differences. So if we look at the code, you can see what happened is the styling has just moved to a separate file, the USS file. But otherwise, everything is the same. We create our visual element for our row. We have three children: label, text field, integer field, and we set their initial value and text. And then we add the whole thing to the root as the second child, which brings us the second row here, USS. Now, there are some differences. This time, for the row visual element, I gave it an actual name, row, and I also give it a class, container. Classes here are the same as classes in CSS. They are just a way to assign the same tag onto multiple elements that are otherwise different, and use that to apply the same style on all of them. So the styles have moved to a style sheet, which we add to our row visual element using as style sheet path, which is a separate file. So let's look at that. If you know CSS, this will look very familiar to you. I know that I want to apply the same font size and font style to all my elements in the row. So I just match on all the elements with this star. For the label, I match on the label C# type. So this is the same as the C# type label. And I use it to assign the background color and width. For the row visual element, I have three options. I can match on the type again, visual element. I can match on the class with this dot, so this container class. And I do match on that to set the background color and the margin. Or I can match by the name with this hash. And this is the same syntax as CSS. For the fields, I go back to matching on their type. And this is where I set the fields, the background color on the integer field and its width. And then something I couldn't do in inline C# is I set the hover effect. So when the mouse is over this text field, the style will change to set the background color to yellow. And it will know when the mouse leaves to set it back to the default. Okay, going back to Unity. If we, in our debugger, if we select the USS row, first we see that because we give it a name and a class, we see that in the debugger, which makes it a little easier to identify. And also, down here, we can see all the styles that are being applied and which style sheets they come from, which line numbers. We also see that every element has a default common style sheet, so we don't have to worry about inheriting from a specific style. We always get that with the types, the C# types. And then we can start overriding the values with our own styles. Down here, we see all the style properties and their values. We can make changes to them. We can hate our changes and change it back. And if we want to see all available options, we show defaults. And this is all the properties that you can change via C#, via USS, or in here. Another advantage of using USS, apart from just separation of concerns, is that you can make changes to it, obviously. But you see the effect right away, and that's because it doesn't have to recompile C#. It just reloads the style sheet and applies the new styles. Okay, now we can go a step further, and we can move the actual visual element hierarchy to a separate file. So in UIElements, this is XML based. The format is called UXML. So we see here the same row being created, but with a lot less C#. First thing is we load our visual tree asset, which is this UXML format-based asset. And once we have this, we can clone the tree, which produces the visual element hierarchy that we can then start using. So once we have that, we add the same style sheet as we added for the USS row, and then we add the whole thing to the root as the third child of the root. And that's how we get this row here, this UXML row, which looks the same. Let's look at this XML file. So as you can imagine, it's just parents. So we have the visual element row. It has the name row, class container, and it has 3 children, label, text field, and integer field. Now, you might notice that we're not setting their initial values anymore. Now, I could say value equals and then give a random value, but I want the values to come from C#. So to do that, I'm going to use the next feature I want to show of UIElements. It's called UQuery. And if you're familiar with jQuery, again, this will look very familiar to you. It lets you query for elements in a hierarchy. In this case, I'm taking the UXML VE visual element that I got from the asset. And inside, I'm looking for the text field by type. And once I get it, I set its value to the value of the tank name on the object. I do the same for the integer field. I can use the full query API to actually query for multiple elements. So in these 2 cases, I take the root and I query for all the text fields in the root. And then here I query for all the integer fields. And I store these queries in a variable because I'm going to use it in several places later in the demo. So that's UQuery. If we go back to Unity, we still have some magic to explain. So for one, this hover effect on the USS and UXML rows, we explained that by using USS, hover pseudostate. But we didn't do this for the inline C#, yet it still works. So to do that, I used the event system. So once again, I use UQuery to get the text field in my inline visual element, which I created way above as the first thing. And on it, I register a callback for the mouse enter event. The system sends various standard events that you can capture, and you can also generate your own custom events and handle them yourself. So in this case, when I get the mouse enter event, I change the background color of the target, which is my text field, to yellow. And then when the mouse leaves, I set it back to clear. So that explains how the inline C# row works. Now the other part of the magic is how come when I change these fields, the object value changes, and also all the fields themselves are synced with each other. So to do that, I also use an event. It's called a change event. Every field will send this event out when its value changes. And here I just go through all of my text fields from the query that I created above here. And I register for the change event, and when that is triggered, I set the value on the object to the value from the field. Now you'll notice that in order to get a list, an actual list to use in a for each of the text fields, I have to call toList on my text fields query. And that's because this is actually still a query. It's a query object. What this lets you do is you can keep a query sort of in a live state. So every time you go and get the list, it's always an updated list of the current state of the hierarchy. Now, I don't actually have to do this. I can simply call for each on the query and iterate through the elements in the query, which avoids an allocation and also avoids extra objects lying around. So that's what I do for the integer fields. I simply for each on the integer fields query, and I provide a callback. And then Because this change event registration happens fairly often in usage of UI elements, we have a shorthand. It's just on value changed, and that just takes a callback for what you want to do when the value changes. Furthermore, because this change event is a change event, it has the values, the old value and the new value in the event. So I don't have to look at the value of the text field. I can just get the value from the event. So basically, these 3 lines do the same thing as these 5 lines. Okay. We also have to explain the other direction. So this only explains the field changing, updating the object, but we also want the object changing, updating the field. To go in that direction, we use the scheduler. So the scheduler in UIElements, you can access it from any visual element using the schedule API. And then you can execute a function either every so many milliseconds or on an interval, or on a delay. So I want to execute something in 5 seconds from now, only once. In my case, I execute it every 100 milliseconds, and what I do is I go through the same queries I had before, and for every field, I set its value to the value from the object. So that means that when the object changes, within 100 milliseconds, the field will also have its value updated. Okay. Now, this pattern of linking UI to an object is going to happen pretty frequently, especially if you build inspectors. So to address that, we have binding support. So this will create the bindings between the object and the UI for you, and it will also generate part of the UI for you from the object's types. So to create this 4th row here, which looks exactly the same as the first 3 rows we created, and also behaves the same, all we do is we have these 2 lines. We create an inspector element, which is a visual element, give it the tank object, and then we add it to the root. Now, this is not quite enough. If we just had these 2 lines, it would still work, except it would give us a default inspector, what a default inspector would look like, which is each field is in a separate row and it has a label. But clearly we have some customizations happening here. So to customize the inspector for an object, we actually do the same thing as, well, it's very similar to how IMGUI worked. That is, you create a class, you have this attribute on it, custom editor, and it takes a type, which is the type that you want to override the inspector for. And then you inherit from UIElements editor, which itself inherits from editor. Inheriting from UIElements editor gives you the ability to override this create inspector GUI function, which lets you create your own custom inspector. You create it once when this visual element is generated, and you return it. So here I use all the bells and whistles. I have my inspector in UXML defined, and I apply some style sheets, one of which is the same style sheet that we had before, because I want the row to look the same as the other ones. Now let's actually look at this UXML for this inspector, because it is slightly different. So just to remind you, this is the basics UXML that we had for the 3rd row. It just has a text field and integer field. For the inspector UXML, I have property fields. So property fields are equivalent to property fields in IMGUI. They automatically generate the proper UI from the object, from the property they're bound to. So in my case, I have the first property field bound to tank name, which is this variable over here, same name. And it knows that because tank name is a string, to generate a text field. Same for tank size, it knows that it's an integer, so it generates an integer field. What I also get for free is, of course, the bindings. So I don't have to worry about scheduling things, and I don't have to worry about the change events. All of this is done for me by the binding system. So I can just focus on the hierarchy, the layout of my UI, and the styling. And now, if we go back to Unity, you may notice some similarities. This row looks exactly the same as this row, and that is because they are the same row, the same UI. The inspector in my branch here is actually running using UIElements. So this is implemented in UIElements, and it's using the same custom inspector that I defined in here, tank editor. Okay, the last thing I want to cover as part of the basics is the IMGUI container. So the IMGUI container is a visual element that takes a callback, and the callback is essentially your IMGUI on GUI loop. And you can see here I'm calling that function that I abstracted before on the IMGUI demo window that I went through first. And that's why this last row looks exactly the same as this row here in my pure IMGUI editor window. So what this lets you do is, if you have a whole bunch of UI that you already wrote in IMGUI, you don't have to completely abandon that and rewrite it. You can write your core UI in UIElements and then insert your existing UI in an IMGUI container. Okay, that covers the basics. Now I want to go over a slightly more advanced usage of UIElements, and that is floating UI. So here I have a visual element that I can click, hold, and drag to move around, and I can also resize it. Let's look at the code. Here's my floating demo editor window. In the onEnable call, I get the root, I load some UXML, I clone it inside the root without creating an additional visual element, and I apply a style sheet on the whole root. Then, for the square visual element, which is this square over here with this background image, I make sure to set its position type to absolute because I don't want layouting to be done on it. I want to fully control its position. You'll notice here I'm using UQuery again, and I'm querying by name. Then I add two manipulators. On the square, I add the square dragger manipulator, and on the corner, I add the square resizer manipulator. Manipulators are really just ways to organize several event registrations into a mini state machine. So for the square dragger, I register for the mouse down event, mouse move event, and mouse up event. And then on mouse down, I activate the manipulator. I capture the mouse, which means only this visual element will receive all future mouse events, even if the mouse is no longer on top of it. On the mouse move, I update its position from the mouse. And on mouse up, I release the mouse and deactivate the manipulator. For the square resizer, it's very much the same thing, except in the mouse move, I change the height and width of the parent. The parent in this case, because the manipulator is attached to this square, this black square, and I don't want the square to change size, I want the parent to change size. So I have to go up one level. And that's basically it. That's floating UI. That's also it for the introduction to UIElements. UIElements will be released in 2019.1, but it's currently in experimental public API form with documentation, so if you want to start using it, you can. Cheers!